So Richard, you made a big trip here from the East Coast to the West Coast to celebrate our grand opening of our showroom. Generally, what are your thoughts about the reception of the technology we're bringing to bear here with lighting and as well as air disinfection?
I like the fact that you talked about 3 different types of lighting. You've got the sports lighting, which is kind of your forte. You've added into that the human-centric lighting, which is good for human productivity. And now you've added into that the germicidal UV for keeping the air clean. Better indoor air quality, better COVID prevention, influenza prevention. So, great job.
And we're always cost conscious, and when you're trying to improve safety and improve indoor air quality, you're generally talking about spending more money. And when you're trying to defeat a threat like COVID or some other airborne pathogen, safety is obviously a high priority. Tell me why Upper Room GUV solve both at the same time, both the cost-effective nature and the much higher levels of safety.
Well, I think if you really think about it, some of the largest capital costs in a building are the people, the salaries. So if you have workers that are out because they got sick in the office, that is a cost. People who catch an infectious diseases sometimes have to be hospitalized. That's a very large cost on insurance. It's a burden on society. So having a prevention versus having to cure, Dr. Berkner, who I worked with for many years, he said prevention is always better than cure. And so really what we're looking at is UV as a preventative technology. It doesn't matter whether a pathogen becomes resistant to antibiotics or vaccines, UV is always going to work. And so it's really kind of a engineering antibiotic that's always going to work.
Sure. And from again, looking at the typical indoor air quality solutions, which are usually rooted in the HVAC world, we know when we increase the air changes per hour, we're spending money, a fair amount in utilities to do that. And the thing that intrigues me about Upper Room GUV is you can achieve quite high effective air changes per hour without paying that utility penalty you do on the HVAC side. Is that one of the biggest advantages that it offers?
That's one of the biggest advantages, is that you don't have to increase the size of your fan or have a very dense filter, which is expensive and causes more energy to be consumed. So you can get the same benefit from basically the cost of running a fluorescent light. So it's very cheap from an energy standpoint compared to other technologies that are more energy intensive.
Sure. So Richard, confidence in the solution is really what we need, I think, in part to get the marketplace to warm up to this amazing technology. What if I was looking for confirmation that, this is well vetted and supported by a scientific community, where do I go to see that?
You can go to the CDC, US CDC. They recommend Upper Room UV as one of the environmental controls for airborne transmission. I worked with the World Health Organization. They did a systematic review of the literature on various controls, and the panel of experts came up and said UV is something to be recommended for TB transmission reduction. And you also have ASHRAE itself that is recommending the use of this. They have a new guideline on bioaerosol transmission. It's one of their most recent things from their board of directors. And they recommend GUV as well as filtration and ventilation. So you can see it right on their website that this a high priority within ASHRAE to actually apply UV effectively. And then we've also had introductions to the White House Office on Science, and they are looking into germicidal UV as a part of the solution to airborne transmission of diseases.
So the scientific backing is there for a long period of time. This isn't a new technology. It's out there, it's supported by the experts, and it's well documented what it takes to be effective.
Exactly.
So when we talk about safety, obviously, which is the high priority of anything we do, where do you lean on to say this is the authoritative expert that says, yes, it's safe, and here's how to do it?
There's several different sources on safety. the work we did with the tuberculosis ultraviolet shelter study. We ran that UV upper room systems in 14 different buildings, 1,200 fixtures in 6 U.S. cities in very high-risk settings of homeless shelters. And we only had one safety issue, and that's where somebody moved too close to a fixture. We resolved that by changing something and no further problem. We ran the study for 7 years, and it showed that it was a very safe application. In addition to that, I chaired a CIE committee, the Commission International Éclairage, which is an international body looking at various lighting standards. And there was one on UV safety, and it showed that it was highly safe. You get more UV exposure from being outside from sunlight than you do in a traditional upper room application. In addition to that, there have been other groups like the American Council of Industrial Governmental Hygienists, ACGIH, and they set threshold standards for occupational safety and health. And they have recommended, that if you keep within certain safety limits that they have prescribed, you can have safe installation. So we teach people through the ASHRAE process how to apply those threshold limit values correctly, and it should be easily, kind of blanking here. You'll have to cut the tape, John.
John's good at that.
If you keep within the ACGIH limits, you should have a safe installation. And plus, we know that people move around. It's not like you're going to be staring at a UV fixture for 8 hours a day. You move around, so people rarely would get to the threshold limit value that ACGIH is recommending. So all these types of principles are within the ASHRAE guidance. The Illuminating Engineering Society, IES, has RP 44, which also describes the safety of germicidal UV. And they've just come out with a IES RP 27 that talks about the ACGIH standards as well. So there's a number of resources that have been well vetted that prove that if you follow these guiding principles, you can have a safe installation.
And it's not like this is new technology either. So
no, it's been around since the late 30s. So it's not like it's the new kid on the block.
So it's proven to be highly effective and safe.
Exactly.
We know this has amazing safety enhancements to indoor air quality. Give us an idea where you see this most likely being helpful and needed in society.
I think right now, one of the primary things that we need to think about is the educational systems, and especially the schools. The schools were unreasonably locked down during COVID. They could have been opened up with UV solutions. So now that there are resources available to improve the schools, that needs to be looked at very carefully so that we can apply UV as a part of the solution, moving forward.
And what kind of activities do you think are most risky? When I think when COVID first hit, I think of the choir practice where most of the choir got sick, and of course people are exhaling fully and breathing in, and they, even though they were 6 feet apart, they still got infected, which of course we know aerosolized particles are going to move more than 6 feet. What are some of those activities that in an indoor environment that tend to be more risky?
That's a hard question to answer because part of, and I'll give you the technical reason for it, and you're going to cut the tape on this anyway, is because, everybody reacts differently. There are the super spreader cases, so you could have had just one highly infectious person that could have exhaled a lot of virons that infected a lot of people. And then you could have another person who had COVID, were exhaling virons into the space, but not at the same quantity level.
Sure. So it's a concentration issue. It's
a concentration issue. So risky, I think part of it is that we have to think about all types of solutions. Sometimes it's going to be spacing between people. You know, you don't have as many people crowded into a space. You need to have your engineering solutions, ventilation augmented with UV, and then in some instances where it's super crowded, you're going to have to wear a mask, you know, to not so much that you're going to protect yourself from inhaling it, but if somebody's sick, it's a barrier from them spreading it out to other people.
And so it seems like you could make an argument that upper room GUV should be a safety investment in a building, much like a sprinkler system. Do you see that in the future, that this will be part of just basic building design?
I think so. I think it will certainly have to be looked at as a built-in solution. I think part of the way UV is approached, upper room UV right now, is retrofitting it into spaces. But you can get more efficient designs if you think about it as a solution going into a building design as well. So it should be part of all new construction as a consideration.
And as ASHRAE develops these guidelines and standards, I guess the important piece of that is then getting into that design phase to the mechanical engineers and the architects, so they start to have this as a go-to solution.
Right, and there are certain accreditation groups like the LEED U.S. Green Building certification for real estate, and now there is the new WELL standard, and both of these types of real estate building certification processes are looking at UV as bonuses within the indoor air quality, and we've had conversations with them about getting the ASHRAE information into their standardization process, so that people going to say, I have a platinum building or a WELL standard level, whatever, that it considers UV as one of those solutions for that kind of certification. If you think about it, a lot of places where UV upper room has been applied has been developing countries where they have endemic tuberculosis, and it's where you know, people are living with TB and dying from it, and so a lot of those places are naturally ventilated, but ventilation that's natural doesn't always blow. So you're not always getting that dilution effect. So you need to have UV to augment the ventilation system. Even if it's very energy efficient like natural ventilation, it won't disinfect all the time because it's not a constant resource, whereas UV can be turned on and kept as a ongoing disinfection strategy. So I think that for indoor buildings, I think indoor spaces, UV is a natural for keeping them safe from the risk of transmitting airborne diseases.
You know, there's a lot of ESSER money that's out there to fund these kinds of projects, and upper room germicidal UV qualifies for the air quality improvements. For a school superintendent to want to invest in this, what's holding them back?
Part of it is probably they're not fully aware of the capabilities of how this technology works. It's been an approved technology for 80 years. It's been used in schools since the 40s. And many people are looking at it today as a solution for preventing not just COVID, but also influenza, measles, and other airborne infectious diseases that circulate in school systems. There was an example of somebody who learned about your human-centric lighting, and now they've come back because of that to learn about air disinfection with GUV. So part of it is people having applied it and telling their stories.
If I were interested in this and I thought, well, that sounds like an interesting technology, what could you tell to me that would get me over the hump, that would give me the confidence that this technology is proven and backed by the experts?
Well, it's been applied in the healthcare arena for, over 50, 60 years successfully. It's in a lot of microbiology labs. The Department of Defense is using UV. Other agencies. EPA is looking into it. Department of Energy is looking into it. So they see the benefits of UV being a win-win from an energy standpoint as well as indoor air quality. So I think that there's growing recognition that we have to have solutions, and UV is a part of that solution.
Well, Richard, I really appreciate you making the trip out here to Gig Harbor and seeing our new showroom. It was great to hear you speak. I'm sure people took a lot home from that, and we really appreciate the great work you're doing with ASHRAE. So
thank you.
Thanks for visiting us.
Thank you very much, Scott. Appreciate it.